Hi, my name's John. Welcome to the second part of the review of this Artec 180 amp inverter MIG welder. In this part of the review, I've put a plug on the welder so I can power it up. I'll show you what the various warning lights do. We'll open and roll a MIG wire. I'll show you how to install a MIG wire into the machine, how to set the torch up, how to put a new tip in, how to put the shroud on. We'll connect the welder to a gas bottle for the shielding gas. I'll explain to you how MIG welding actually works. Then I'll do a little bit on safety and hopefully we'll get some welding done. The controls on the front of the welder, there's a switch there which switches it between stick welding and MIG welding. That control there controls your voltage, your welding voltage. That one controls your wire speed. It's a combination of the wire thickness, the voltage and the wire speed which gives your welding amperage. There's an LED display there which shows the actual welding amperage when the machine's being used. If you're going to use this machine to weld structural steel, the welder will need to be calibrated, and they use that to calibrate it. This control here is for your amperage for your stick welding, your MMA welding. We'll discuss that more when we come to do some stick welding. There's three warning lights. You've got a green one, a power light. That one there is an OT light, over temperature. If the machine exceeds its duty cycle, that light will come on, and the machine will also cut out because it's got a thermal protector in it. That's a red warning light, you don't want to see that one. I'll talk a little bit about MIG wire. The machine takes 5 kg spools of MIG wire, or 1 kg spools. This is a 5 kg spool. Artec actually supplied this wire. You can buy the wire anywhere. Make sure you buy good quality wire. There's one thing you should know about MIG wire. It's actually horrible stuff. It's only got one real ambition in life, that is to get off this spool onto the ground. Okay, protect the paper of it. The MIG wire, it's metal steel wire, but it's actually copper coloured. It's got a very thin copper coat on to help prevent it rusting. If the wire has any rust on, you're wasting your time using it. Throw it away and get another roll. Right, the MIG wire is actually a little bit like a live grenade, and that's the pin that fires a grenade off. At the minute, it's nice and dormant, and the wire is tied off through the side of the spool. Once you untie it, the roll then becomes live, and the wire's ambition in life then is to get off the spool. That's not going to happen because we're going to be careful with it. Right, we're inside the welder. We've got our roll of wire, we've got a pair of side cutters, use them all the time when you're MIG welding. This is actually 0.6 wire. The welder can use 0.6 or 0.8. I'm going to start off with a 0.6. This is the wire feed mechanism. I'll show that in the last video. That simply opens like that. The spool of wire goes onto here and it feeds off the bottom of the spool, through that guide, across the top of your roller, out through the liner and through your torch. First thing we need to do is put the roller wire on. There's a nut, a spring and a guide. That's where the wire is going to come off. That's the grenade pin. That goes at the bottom. Wire simply goes onto there like that. That locates it. The spring goes on. And the nut screws onto there. What the spring does, it puts a little bit of tension on the roller wire, so when you come to stop welding, if you've been welding at a high wire speed, it stops the spool from running on and the wire from bunching up inside of here. Right, so what we've done, we've lifted our tension roller. We need to get the end of that wire, slide it through the guide, over the top of the roller and through the liner. Right, so we're carefully take it out of there, cut the end of the wire nice and clean, you must not lose control of the end of the wire. If you lost control of it and you drop it, you'll have problems. Right, so you've got the end of the wire, it simply goes through with a little guide tube, pushes through. I'm trying to work with the top of a camera here, it's a little bit awkward. And it pushes through like that. Right, it's just come at the top of the roller. I'll get a close up of that. Right, you can see how the wires just come over the top of the roller. You keep pushing it through until it goes up the guide tube on the other end, like that. We'll then close our feed mechanism, and that's spring loaded, so it puts tension onto that roller. Right, I'll turn the machine on. And you hear the cooling fan running. Right, if I press the MIG torch now, you can see the bottom roller spinning, pushing the wire through. Right, when I press the trigger on the torch, you can see the feed mechanism is pushing the wire through. Keep the trigger pressed until the wire comes out to the end of the gun. Right, that's the wire out the end of the gun. Turn it off. Once again, cut the end off nice and clean. Right, so the wire's coming out the end of the gun. That's a tip, what they call a MIG welding tip. This is a 0.6 one, because that's 0.6 wire. You can buy these anywhere, they're readily available. That simply slides over the end of the wire, screws into the torch, a little nip. You actually get a nice little spanner with a welder. So that's our wire through the end of there. And we've got a shroud, a gas shroud, that simply goes on the end and pushes on like that. We've got our spool of wire into our machine. You can see it feeding off the reel there. That's the control for your wire speed. It goes from barely moving up to really feeding wire. Right, next thing is we need a supply of gas. MIG welding stands for metal inert gas, the metal being the wire, the inert gas being the shielding gas that we use to stop the welding from oxidising. This is the gas hose and the regulator of my welder, because I want to keep the one off as new. There's a connector on the back of the welder. Gas pipe simply screws onto there. Just a gentle nip, that's all it takes. That's the gas into your welder. This is the gas I use for MIG welding. It's what we call Sure Shield 5. It's a mixture of argon, oxygen and CO2. Mainly argon, a little bit of oxygen, a little bit of CO2. One bit of advice with a bottle like this, tie it to something. My welder's normally on a trolley and the bottle's tied to the trolley. It takes nothing to put a little bit of rope around it and tie it to something like that, so it can't fall over, because you can guarantee you'll put your regulator on there and you'll be welding, or you'll walk by, you'll bump it and it'll fall over. So secure it to the bench, or better still, get a proper trolley for it. This is a 20 litre bottle. You can use a smaller bottle or a bigger bottle. Some people use what they call pub gas, which is straight CO2. It does work, but it's not as good as the proper stuff. Before you screw it into your bottle, just gently crack the valve to blow any shite out of the threads. Just like that. The gas in here is at a charge pressure of around 2,500 psi. The welder needs a pressure of somewhere between 5 and 10. So what we use a regulator which regulates the pressure between whatever's in the cylinder to a low pressure for your welder. The welder comes with a regulator, like a twin gauge regulator. One gauge shows your bottle contents and one gauge shows your output pressure into your welder. Regulator's ordinary thread. Flammable gases are left hand thread, acetylene, propane. Shielding gases and oxygen are right hand. You need a good fitting spanner or a quality adjustable, you're probably better off buying a proper bottle spanner. I've actually got a one. Right, so just nip the regulator in, you haven't got to go ridiculous with it, just a little nip. Right, on the other end of the hose from your welder, that simply screws onto the regulator. And that gets nipped up. The regulator's fully unwound. When it's in that fully unwound stage, it won't pass any gas. Right, I turn the bottle on. That gauge there moved. That's your bottle contents pressure. This one's just on that 2000 because it's a used bottle. That's your outlet pressure into your welder. We'll turn the welder on. I'll turn the wire feed rate down and pull the trigger, and we'll be able to set up our welding gas pressure. Right. Right, you can hear I can hear the gas coming out the end. Right, that's your bottle content, which is shown just on that 2000. That's your welding gas pressure, which is running just below 10 psi. When you're finished welding, make sure you turn the bottle off and back your regulator off. Takes the pressure off the diaphragm inside the regulator. It's not a bad idea on your initial hookup, just spray a little bit of soapy water around the fittings just to make sure you've got no leaks. Right, I want to do a little bit about safety, welding safety obviously. Welding processes involve quite a few hazardous things. You've got electricity, you've got high amperages, you've got radiation, ultraviolet rays that'll burn your skin and damage your eyes, you've got high pressure gas. There is some simple precautions we can take to minimise the effects of all of these things. Don't use a welder outside in the piss and rain. It's not rocket science. When you're welding, use a proper welding mask or welding screen. If you look at the welding arc, it'll burn your eyes. You get what they call arc eye. It's not nice. I've had it. You don't want to go there. I use an automatic changing screen. It changes from being able to see through to dark weld instantly as soon as you weld. This happens to be an Artec one. There's loads on the market. This is as good as anything I've used. One thing about it, it's got a button, what they call a grind button, so you can turn it to grind mode, and it's a light green tint, and you can use your grinder without getting shite in your eyes, because it's so tempting just to lift your visor up for a quick grind. That's when you get problems with mucking your eyes. Right, as far as heat goes, wear gloves. I normally wear TIG welding gloves when I'm using a lightweight MIG like this. It depends how far you want to go. You must have no parts of your skin exposed. Not only will you get burnt off sparks, the radiation will burn you. It's a bit like sunburn, but a lot worse. You can get yourself into a right mess with welding burns. You can wear leather jackets, but generally a set of cotton fire retardant overalls are all you need. And make sure all your skin's covered up. It's no good having a t-shirt on like this. You cover your arm, cover your hand. That bit there, it'll get burnt red. You won't feel it being burnt when it's happening, but you'll certainly feel it 2 or 3 hours later when you're in the hospital. They're trying to cool it down and your skin's all peeling off. So make sure you've got no exposed skin, a decent helmet, good visor. Like I say, an automatic change visor, they're ideal. Whoa, look at that bastard. Right, this is what you don't want to happen.